introduction. And thank you everyone for having me today. Today I'm representing a team of 3 people from Elsevier. My colleague Chris, who worked on the introduction of the paper mostly, and the literature research. My colleague Eleonora Palmaro, our data scientist, who extracted the data for us and worked on the methodology, and myself, who did the analysis for the paper. So it's a great pleasure to be here. I am from Elsevier, and you might know us as a publishing company, but we have been transforming into an information analytics business. And my team is called Analytical Services. And what we do is we specialize in research performance and providing some insights to our customers, which are government organizations, funding bodies, research-intensive institutions, and also research-focused companies. So how is Elsevier an information analytics company? Well, we have a lot of data. And for this paper, we used 2 of our data sources. One of them is Scopus. You might be familiar with it. It's the largest abstract and indexing database. And we use these data for number of papers and number of citations. We are also using Mendeley. Stacey mentioned this source earlier on. It's a literature management software that has evolved into kind of a social media platform for scientists. You can follow people on Mendeley, you can make recommendations to literature, it even alerts you as to stuff you might want to read. And we use this as a source for what we call readership or reads. And basically, if on Mendeley I save a paper into my library, then that would count as a read. And what we wanted to do is we wanted to test whether it would be possible to field weight the Mendeley reads like we do for citations and what that indicator would look like. So a few key findings from our study. We found that there was a strong correlation between publications read and cited at country level, which is to some extent a function of size, of course, and that the geographic distribution of Mendeley readers also plays a role. However, we also found that there was a strong correlation between field weighting readership and field weighting citation, thereby eliminating the effect of size or specialization effects. And for most fields except humanities, there appears to be a small field-weighted readership advantage, particularly pronounced in agricultural sciences and social sciences. What was very interesting was that the variations that we saw per country tended to also pervade at field level per country. So let's dive into the data. And this is basically the same chart with the cited publications on the y-axis versus the read publication on the x-axis at the country level. The chart on the left includes the world and all the countries in our data set, and the one on the right is only for the most prolific countries in terms of number of paper. So beyond the correlation that is due to the size, I think what is quite interesting is to see how some of the countries perform. So for example, you see China tends to have relatively more cited publications than read publications. And the opposite is true to a lesser extent for the US. If you look at these countries here, you can see quite a few research-intensive Asian countries that also have this pattern of more cited publication relative to read publication. And conversely, in the group of countries with relatively more read publications than cited publications, you find a lot of Western research-intensive countries. And when we looked into it, we found out that there is probably an effect of the geographic distribution of Mendeley readers here. When you look at the data with the number of publications in orange and the number of readers in blue, you can see that, for example, the US has many more readers than it has publications, and the inverse pattern is true for China as well. So trying to look beyond these absolute numbers and the size effect, we decided to look at normalizing. So we are normalizing for size. The field weighting indicators that we use are mean citations or mean reads per paper. So effectively, we can compare a small research nation like Singapore to a big research nation like China. It also accounts for age. if you think that, for example, an older article has had more time to accrue citation than a more recent one. And it also accounts for article type, knowing that reviews tend to be cited more than research papers, and for article fields. We know, for instance, that there tend to be more citations in life sciences, and they appear quicker than in other fields like mathematics. And the way our indicator does that is by looking at the whole of the database and seeing what is the expected number of citations or reads that a paper of a particular age, of a particular type, and of a particular field has, and comparing that to the actual number of citations received per paper. So what we have then is this indicator that tells us, okay, 1 is the absolute average, higher than 1, better than average, lower than 1, less than average. And when we look at the field-weighted indicators, we see that the correlation is not solely due to the size. There is still a very strong correlation between field-weighted citation impact and field-weighted readership impact, readership being on the x-axis and citations being on the y-axis. And we have the same two charts with, here we have the countries with more than 1,000 papers and those with more than 10,000 papers for 1 year of data. And what is interesting is that we see some similar patterns. For instance, China still tends to be cited more compared to how red it is in terms of its research output. But the picture is not so clear-cut in terms of the countries that appear below and above the line. There is quite a mix of the characteristics of the countries here. What I found particularly interesting was that the variations per country tended to hold true per field. So, for instance, we mentioned that China tends to have a research that's relatively more cited than red, according to Mendeley readership, and that holds true for fields like agricultural science, engineering, medical science, natural sciences, etc. And another example is India, where we found similar pattern, but inverse patterns also holding true for all fields. When we looked at the absolute values of field-weighted citations in red versus field-weighted readership in green, we found that especially for the fields like agricultural sciences and social sciences, there was a slight field-weighted readership advantage. And when we broke the data down by country, we saw that it was driven mostly by the Western research-intensive countries like Germany, France, Great Britain, and the US. And we found the opposite was true for prolific Asian nations like China, India, and Japan. So, a few conclusions from us. There is this size effect, and it drives the correlation between number of papers cited and number of papers read, but that is not the whole of the story, because we still see a strong correlation when we look at the normalized indicators. The variations per country also apply generally for the fields. The geographic distribution of Mendeley readers has a role in the patterns that we observe in the data. And overall we found that field-weighted readership impact seems to be a robust metric that offers some interesting insights because it provides information on the different parts of the scholarly communication cycle. Finally, and of course, we do welcome further analysis. I think it will be good to look at other aggregation levels beyond the country. Does it still work? If you look at institutions, for instance, or research group. We'd also like to see how it compares to other indicator types like downloads, views, or other autometrics type. And thank you very much for your attention. If you have this one?
Yeah. Thank you.
Welcome.
I just wanted to read that.
Thank you. Enjoy. That was an easy one. Do you have any other easy questions like this?
Well, I would ask ask one question? Because you mentioned downloads just in the last. Did you look at downloads at all?
We did look a little bit, and I think that's going to be part two. We want to do further analysis on this. We couldn't get to anything conclusive in time for this workshop, unfortunately, but that will be the next stage. And then for us, there will be two questions. Do we want to look, I think we had a dilemma we couldn't solve, basically. Do we use Scopus download, which means when someone is in Scopus and they click, go to full text, or do we use Science Direct downloads, which is restricted to material from Elsevier? And both have advantages and disadvantages, and we need to look more into the data and the analysis to decide which ones we can use and how to put it into the analysis.
Great, thank you.
Thank you.
Is there another question?
Yeah, I have a question. I may have actually missed the definition of, cited and read.
Oh.
Can you explain a little bit? Because will that have, the accessibility of, of researchers to resources have an impact on, the numbers?
That's a very good question. Thank you for that. Thank you for asking. I'm sorry if I was a bit quick explaining. So the citation would be whether somebody makes a reference in their paper to another paper, so as part of literature review, for instance. And the readership is whether someone saves a paper in their Mendeley library. So of course, they need to be a Mendeley user. Mendeley has millions of users worldwide because it's a free tool. But yes, there would be a... Oh, my microphone is dead. So I will shout a little bit. So it depends whether people have access to the software or not. If they have a computer, thank you. If they have access to the internet, then obviously they can. That will be the main restrictions, and if they're willing to use the system.
Yeah, thank you.
Thank you.
Another question here?
I have two questions. The first one, how many data that you have gathered for the analysis?
Oh, that's a good question. The analysis was based on 1 year of data, and the publication, so if I can go back to the absolute numbers. Here we go. So, for instance, the whole data set was about just under 8 million citations and 350,000 read.
And my second question, are the data gathered, is it include the retraction papers?
That's a good question. Thank you for asking. So it will include anything that appears in Scopus. So that's so that will be about 8 million papers for these 5 years of data. But so retractions, it works the same as in the database, right? So if you publish a paper, it's in and it stays in, and then when the retraction comes, that counts as another paper. And then the citations to the original paper and the citations to the retractions will also be counted, and the same for the REDS indicators. Does that answer your question?
Thank you.
Thank you.
Great, well, thank you very much.